All right, we have finished chapter 1, which was the algebra part of this topic. But remember, this is algebra and surds. So the chapter 2 part, well, I called it algebra and surds. The full long name was whole numbers, integers, and rationals. But I thought surds was a bit, algebra and surds flowed a bit better than algebra, whole integer numbers, integers, and rationals. Okay? So this is the start of chapter 2. Your first test is on both of these two topics. And this first little exercise, I think you'll find is quite a nice one. And we're only doing this one little exercise today. So, first of all, let's go through our little set of notes here at the top. Whole numbers. We know what whole numbers are. Whole numbers are things like 0, 1, 2, 3, 4, 5, 6. Every whole number except 0 and 1 are either prime or composite. So remember that prime means that you have exactly 2 factors, which is itself and 1, and composite means you have many more factors than that. Could be 3, 4, however many factors. That's why 1 is not considered to be prime, because it only has one factor, which is 1, and 0 doesn't really have any factors, okay? So every other number is either prime or composite. The set of whole numbers or counting numbers is denoted by the letter N. So if I was trying to list off the set of counting numbers, I would say N is equal to, and it's like in probability. We put those curly brackets in there. This is my set of numbers, 0, 1, 2, 3, 4, 5, 6, continuing on from that. So that letter N represents whole numbers. Integers, however, is the next group out from whole numbers because it extends into the negative numbers. So we still have all our 0, 1, 2, 3, 4, 5, 6, but we also have the negative 1, negative 2, negative 3, okay? So we go into the negative numbers. The letter we use for that is this fancy Z here from German Zahlen, meaning numbers, okay? So we would use Z equals, and we would write it like that. Rational numbers are any numbers, like including decimals. If it is possible to write it as a fraction, then it would be a rational number. So integers or whole numbers can be written as fractions because 5 is just 5 over 1. It is still a fraction. And we give the letter Q for our rational numbers. We're going to be finding some percentages. And you know that percentages mean out of 100. To convert a percentage to a fraction or a decimal, you replace the percentage sign with a divide by 100. I don't really like that way of thinking about it. Instead, you may, if you're like me, you might be thinking you've got fractions and decimals that are basically different forms of the same number. You don't have to multiply them by anything. If you're using your calculator, I did this in my year 9 class today. If you're using your calculator, so that's when you press the SD button. Okay, you got the decimal and then you want the fraction, you press that SD button. That's all you have to do to convert between fractions and decimals. But if you want to go to a percentage, fraction or a decimal to a percentage, you have to times by 100. But if you have the percentage and you want to go back to the fraction or the decimal, you divide by 100. So I find a diagram like that makes it easier to deal with. Sorry? Are you recording? Yes, I am. Thank you. Okay, so there's only 2 examples here. It's a very short little one today. A gold-plated calculator marked at $230,000, because it's gold-plated. Be grateful you don't have to buy it. Has been discounted by 15%. How much does it cost now? Well, some of you might want to find 15% and then subtract it off. But the shorter method is to say, if I want to discount something by 15%, it means that I want 85%. All right, you've got 100% is the total. If I subtract off 15, I want 85%. Now, 85% of, because percent means divided by 100, if I times that by the $230,000 calculator, my calculator has been discounted to $195,500. Okay? Does anybody want me to show you how to do it the other way? No, you happy with that method?
Yes.
Happy with that method? Or was that a yes for the other way?
Yeah.
Yes for the other way. You want me to show you the other way, or are you happy with that?
No.
Okay. Okay, I'm just going to annoy you. Alright, question 2. Our gold-plated calculator is discounted by 15%, and it now costs $230,000. It almost sounds like the same question, but it's not. In the first question, the $230,000 was my starting price, and I wanted to discount that by 15%. But the way this is worded is saying that $230,000 is the discounted price, and I want to go back and find out what the original price was. Okay, so in terms of a percentage, yes, not 15, sorry. I want to take 15% off 100, so it's 85% again. But it's 85% of the original price. But that's what I'm trying to find out. So I'm going to call that X. 85% of the original price is going to be equal to the price that I've been given of $230,000. Okay? And I just have to rearrange that to get the X by itself. So if you want to, you could write that as 0.85x, just turning that into a decimal. And then you would just divide by 0.85, and you would get that the original price of that calculator was $270,588.24. But can you see the difference in those two questions? When you read them, just be careful with what they are saying. Do I have the discounted price, or am I trying to find the discounted price? Which way am I working here? All right, and that's it. Most of the questions that you're doing, I'll just